Hello friends, myself Darshna Patel, working as an assistant professor at V.S. Patel College of Arts and Science BCA BBA course. I am over here to teach object-oriented programming using C++. This is second video of my lecture series on object-oriented programming. So if you have not watched first video, then I request you to watch first video and then watch this video. In today's session, I am going to cover basic concepts of OOPS. Basic concepts of OOPS. OOPS is also known as object-oriented programming. So, object-oriented programming is a programming concept that works on the following 8 principles. They are class, object, data abstraction, encapsulation, inheritance, polymorphism, dynamic binding, and message passing. Now, let us look at each of these in details. Class. Class is a user-defined data type. This means that user can create data type according to his needs. For example, if a user wants to work with student data, he will create student class. And if he wants to work with teacher's data, he will create teacher class. Class has its own data members and member functions. This means that the class or user defined data types the user creates will have its own data members, that is variable, and member functions to manipulate these data variables. A class is a blueprint used to create objects. This means that the class created cannot be accessed directly by the programmer. To use this class, we need to create an instance of that class known as object. That is, instance of a class means object. Let us understand this with an example. Suppose you want to build a building. You will first get plan or blueprint ready for that house. And then you will start constructing it according to the blueprint. In the same way, class is also blueprint. It does not have memory and class cannot be used directly. So we need to create objects to use this functionality of the class. As shown in the image, car is a class and Polo, Mini, Battle, I-10, I-20, etc. are objects of car class. Objects. Object is an instance of a class. That is, object is a variable of type class. So when a class is defined, memory is not allocated. But when an object is created, memory is allocated to that object. Object is a runtime entity in object-oriented programming. So runtime entity means that the things that exist only during program execution somewhere in the memory. They do not have their life outside program execution. Now since object is a memory area created at runtime whose address or reference is accessed by reference variable, and so objects are known as runtime entities. Object represents real world entity. This means that an object may represent physical as well logical entities that exist in the real world. And these entities can be a person, place, animal, bird, or things. So, or it can also be logical entities such as bank account. An object has a state and behavior. Now, we know that object represents real world entities, and real world entities have state and behavior. So, object also has state and behavior. Here, state means properties or attributes or data. Say, for example, name, email, phone number, birth date, etc. are properties of a person. And behavior means the method or functions or actions that are performed on this data to obtain the desired result. For example, a function to calculate age from birth date, or a function to get full name of a person, etc. As shown in the image, car has properties such as gear, model, speed, fuel type, etc. And it has methods or functions such as applying brakes or changing gears, etc. We will be covering most of the concepts of object oriented programming in detail in coming videos. Data abstraction, the act of representing essential features without including the background details or explanation, is known as data abstraction. Thus, data abstraction means only selecting the necessary or required attributes from a large pool of attributes and thereby showing only the relevant data of the object to the user. This means that we select only those attributes that are needed for our software and we ignore the other attributes that are not needed for our software. Let us understand this using a real world example. Think of washing machine. We use we just put clothes, liquid soap and softener inside the machine and then press start button. In the end we get washed and rinsed clothes. So inside it does lot of processing which we are not aware about. Thus, data abstraction reduces programming complexity and efforts. Now, let us look at the example given. Suppose you want to create a banking application, and so you will be collecting information about the customer. The customer will give you following information, that is name, address, birth date, contact number, favorite food, favorite movies, favorite actors, etc. But all the information given by him is not required for banking application. So we will select only those attributes that are needed for our banking application, like name, address, birth date, tax information, contact address, etc. Thus, selecting of essential attributes of customer from a large pool of attributes is known as abstraction. Encapsulation, the wrapping up of data and functions into a single unit, is known as encapsulation. That is, the class binds the data and functions that manipulates this data together as a single entity. Thus, class is like a wrapper around the data members and member functions. Encapsulation is used to hide the internal representation of an object from outside world. This means that the data is not accessible to the outside world. Only those functions which are wrapped along with the data can access this data. Hence, data is safe from accidental changes. The member functions that are wrapped inside the class act as an interface between the object's data and the program. This means that if an outside entity wants to access the data, then it can only access this data using member functions. This insulation of the data from direct access by the program is called data hiding or information hiding. The data hiding prevents the unauthorized parties from directly accessing the data. Now, let us understand this with a real life example. As shown in the image, there is a capsule that contains medicine. Now we know that this is a capsule and it has medicine, but we don't know what mixture of chemicals or what is the chemical composition of the medicine. This detail of chemical composition is hidden from the people. So this is what is known as encapsulation. Inheritance. The mechanism of deriving a new class from old class is called inheritance or derivation. Thus, inheritance is a process by which object of one class acquires the properties of object of another class. Here, old class is called parent class or base class or superclass, and the child class is known as new class or derived class or subclass. Now, let us understand inheritance using example. As shown in the image, there is an animal class. The animal class contains all the characteristics that are commonly observed in all the animals. Now, if we want to create another class for storing dogs information, so we will create a new class called dog class. Now, if we make this dog class as the child of animal class, then dog class will inherit all the properties of animal class. And so, we will only have to add those characteristics in dog class that are not found in the animal class. The same is applicable for cat class and cow class. Thus, we can say that the inheritance concept in object-oriented programming is similar to the inheritance found in living being. For example, a child inherits some of the features of his father and some of the features of his mother. Now, we will be covering inheritance in detail in coming videos. Polymorphism. Polymorphism means one name, many forms. Thus, polymorphism is the ability to take more than one form. In object-oriented programming, the ability to access objects differently depending upon their data type or classes. Thus, let us understand this using real-life example. Say a man is a father when he is with his children. He is a husband when he is with his wife. And he is an employee when he is at work. So the person is same but possesses different behavior in different situation. This is called polymorphism. Now, as shown in the figure, a shape class has three children classes: rectangle, triangle, and circle. And the shape class has a method called draw. Now, polymorphism enables child class to redefine parent class methods, and so triangle, rectangle, and circle will have their own version of draw method. So when a draw method of rectangle class is called, it will draw rectangle. And when draw method of circle class is called, it will draw circle. Thus, no matter what shape an object is, draw method will draw correct shape. This is what is known as polymorphism. We will be covering polymorphism in detail in coming videos as a separate topic. Dynamic binding. The association of method call to the method body is known as binding. Thus, binding means linking of a procedure call to the code to be executed in response to the call. Thus, binding means what code to be executed when a function is called. Now, there are two types of binding. Static binding is also known as early binding. Here, the binding can be resolved at compile time by the compiler is known as static binding. And the second is dynamic binding, also known as late binding. In dynamic binding means the code associated with a given procedure call is known only at runtime. Here, the compiler cannot resolve this binding and will have to wait till execution. This is known as dynamic binding. Message passing. Message passing is the technique of exchanging messages between the objects. For example, objects communicate with one another by sending and receiving information to and from each other. This is known as message passing. Thus, objects can send and receive message just as we humans do. In programming, functions or methods are used to pass the message. The message passing includes three things. First, the name of the object. Second, the name of the function. And third, the information to be sent. As shown in the example, employee.salary parenthesis name. Here, employee is the object, salary is the name of the function, and name is the information that is to be sent.